Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode from ID 3443, maximum Manhattan distance after k changes. This problem will be based on the greedy approach, and it is not that intuitive in the starting, but it will be easy for you to understand. Marked as medium on LeetCode, let's have a look on the problem statement. Here we are given a string S consisting of the characters N, S, E, W, north, south, east, west, where SI indicates the movement in an infinite grid. N means move north by 1 unit, move south, move east, move west by 1 unit each. Initially you are at the origin. Okay, so it is given in this way that we are given a string like this N, W, S, E, and this string mean and this N, W, S, E mean that starting with the origin, we are starting with origin. If it is N, move to the north, move to the west, and so on, and then find the maximum Manhattan distance from the origin. That can be achieved at any time while performing the movement in this order. Okay, when we are performing movement in this order starting with 0, 0, and at any moment whatever can be the maximum Manhattan distance. And what is that distance? Manhattan distance between two cells x1 y1, xi yi, and xj yj is this. Okay, so we have to find out the Manhattan distance from origin, and origin is always 0, 0. Let's say this is the farthest point we are able to reach you following these directions. Then what is the distance between these two? X, y. So it will become modulus of x plus modulus of y. So this will be the distance, Manhattan distance. Okay, so here in this case what I'm trying to say is that x1 y1 is 0, 0. So if it is 0, 0, remove it, xi mod plus yi mod. So that is the distance. Okay, so in this case, if let's say I'm able to reach to this position x and y, so whatever is the magnitude here and whatever is the magnitude here, the sum of these two values is the Manhattan distance. Okay, so this is given to us, and there is one line that you can change at most k characters to any direction, any of the 4 direction. So when we are following this path, let's say initially if I try to follow the same path, initially I started with 0, 0, covering north coming here, west coming here, south coming here. If I follow the south, it is coming closer to the origin, but instead of this, if I convert this south to north, it is going away from the origin. In this case, we'll be able to get more Manhattan distance, and for that operation k is given to us. We can only perform k number of operation. If we have k available, then we can perform the operation. Otherwise we are not going to perform the operation, and we have to just capture the distance whatever the direction we have. Okay, so this is the problem statement. We are given a string consisting of these 4 directions. It means moving to this direction by 1 unit and find the Manhattan distance from origin. And Manhattan distance is like magnitude from origin. So if the Manhattan distance of this we have to find out, that will be something like this. This portion plus this portion, x plus y, magnitude of x plus magnitude of y. Okay, and whatever can be the maximum possible value of this Manhattan distance, that is something we have to return. So yeah, this was the problem statement, and the problem seems to be very simple. If we just skip this, let's ignore this k part, and we have to just go with these direction and find out the distance. If it is north, move to one direction up. It means y plus plus. So if it is just string, it is going to be very easy. So this introduction of k is making it a bit non-intuitive. Now I hope the problem statement is clear to you. First of all, let's try to do the dry run. What will be the possible answer of this in this case? Here we are starting with 0, 0. Yeah, covering up the first direction, that is north, going up, and answer is something I will keep on capturing. Initially it is 0, and after one direction I am able to find the Manhattan distance, that is 1. So currently x is 0, y is 1. So magnitude of x plus magnitude of y is the Manhattan distance. So that is the candidate distance. This is 1 and it is greater than 0. I will update the answer. Now go to the west. If I go to west, I'm going to -1 and 1. And here the Manhattan distance is magnitude of -1 plus 1 magnitude, that is 2. So 2 is updated. If I do with the south direction, the Manhattan distance is 1. Why? Because it is -1 and 0. And now again it is east, so it's already at the origin. So here the distance is 0. So we are not going to update answer. So maximum answer we have got so far is 2 if we have not used this k. So far it is very simple that we are going one iteration over this direction array and performing the updation on I and j. If it is going right direction, x plus plus, x minus minus, y plus plus, y minus minus. Okay, now let's see how k can benefit us. In this case, if I just remove this portion, so far we are incrementing. So far we are getting better answers, 0, 1, 2. Yes, we were getting better. But here, this direction is the first bad move that we took. Okay, instead of south, if I just convert it to north, as we already discussed, if I convert it to north, I will go up and this will become -1 and 2. And what is the Manhattan distance now? -1 mod plus 2 mod, that is 3. Okay, 3 is better, so 3 is updated, but we have already utilized our k. Now k is 0. K is 0, so after this, whatever the direction, just keep on following that. And this is something going to give the Manhattan distance 2. So whatever is the maximum, that is coming from this. And this is because we shifted our direction. Correct? So shifting the direction is going to give us better answer. Let's say when we are here, when we are going in this direction up, if we keep on going in the up direction, we'll get the positive answer. Let's say going up, going up, going up, and going down, our answer is not that great. It means it's a dirty move, and if we are allowed to fix it, just try to fix it. Or in other terms, just going to the right direction, going to the left bottom direction, going to the left direction. Okay, if we keep on going the one direction, then it is good. So if I just try to have a look, here I am going on the left direction. What about, see, we have 4 options: east, west, north, south, horizontal move and vertical move. If I just made a vertical move in this direction, I have to keep moving in this direction. If I have made a horizontal move in this direction, just keep on moving in this direction. Because if we keep the direction like this, later on if we do something like this, I will just try to flip it to the same direction. It means if I am in this plane, just keep on going in this direction. If I am in this plane, just try to keep exploring this direction. If I started with this, just keep exploring this direction. See, what I'm saying is, let's say I'm at 0, 0. I made a first move to this direction and this direction. If I'm making move either this, both are going to benefit us. Both are going to benefit us. So if I'm going in this direction, just keep on going there. So, or follow this direction. So we have decided that these 4 directions are going to give us the good answer. This might sound tricky, but just try to analyze. Let's say that, see, in this question, I started with this and then with this. And now if I am doing the same arrow again, then I will get better answer. And if I am not doing the same arrow again, I will get the wrong answer. So next time, this arrow is in the opposite direction of this. So it is not giving us the good answer. So what I have decided that at least we have to go in these 4 directions. Okay, so this is how we have to think greedy in this question. that these directions are going to benefit us. So what are these directions? East, west, north, south. If it is east or north, one combination is this, second combination is east or south, third combination is west or south, fourth combination is west or north. So we have these four directions. My horizontal direction can go from east or west, and vertical direction can go north and south. So what are these four combinations? East, west, north, south combination. So horizontal direction will belong to east and west set, and vertical direction will belong to north and south. So just check out all the combination. All the combination D1, D2 belong to this. If I check all the combination and try to maintain the direction according to this, let's say it is H and it is V, horizontal and vertical. Let's say this is horizontal character, vertical character. Horizontal character and vertical character is something I have chosen for all of these combination. Then try to keep the direction like this and try to maintain the direction in this order and get the answer. So let's say take the same example, northwest, southeast. K is equal to 1. So here in this case, if I keep on going in these four directions, then I will get a positive answer. So as far as I have valid value of K, just try to explore or try to convert every dirty move to the better move. So what is this those better move? Let's say if I decide that I will go east side and north side, it means this move. If this move is in this direction, just move ahead. This move in this direction, no. So move it, and move it to which direction? East or north? Whatever direction you want to move. Let's say if this is west, and if I just move it to what direction? Let's say north. So it is going to give us good answer. So first one is north, second one is also converted to north. What about the third one? Third one is south initially. So but we cannot go more than one times. So in this case, this is something I will keep on going. Okay. So what about the second direction? Second direction is something west and north. So I will try to keep all of my directions to west and north. This is the string. If it is north from this set, okay, just take it. Take this move. Then take this north, and it is west. West is also in this direction. Take this west. South is not in this direction. Does not belong to this set. So convert south to what? To whatever value you want to take. Just go in this direction. You want to take west, just take west. You want to take north, just take north. Totally up to you. Let me take west. And what about east? East is also not in this direction, but we are not allowed to use it because K value is 1. If the value is K was 2, then we would have converted this also to this direction. Okay, so now I'm getting an idea. If I'm having a value of K present, then I have to do something. Otherwise, I don't have to do something. I will just keep on moving in these four directions and capture the answer. So for every horizontal direction belongs to, what are the horizontal direction? East and west. So for every east and west, vertical belongs to north and south. These two for loops, nested for loops, are going to create a direction, specific direction. Let's say that specific direction at any moment is this, west and north. Okay, so using these two loops, I have created scenario to check all the directions, correct? And now what I have to do is move my S according to these directions. If I have K, so for every character belong to what? S dot character array. Character belong to S dot character array. What I have to do? This is my K. K is something I am allowed to make a bad move to good move. Character is this. So first of all, I need to see if the character is not equal to this, then it is a bad move. But before that, we also need to see if we have the provision to correct a bad move. So if K is greater than 0, then we have to think. Otherwise, there is no need to think of anything. Just whatever is the direction, just move your X and Y according to that direction and just go ahead. And what is my X and Y? So X is initially 0, Y is initially 0. So according to direction, just correct your X and Y and later on capture distance. So what I'm doing, this is my first step, exploring every possible positive direction. Second one is, if I am allowed to make such move so that I can create a bad option to good option, I will do this. Otherwise, if we do not have the option, just go ahead with the flow. Just whatever is the direction is given to you. Let's say you initially as 0 and 1. If it is north means y plus 1, y plus plus. So y plus plus 0, 2. So this logic just put here. And after that, capture the distance. How do we capture the distance? Modulus of x, modulus of y. If this value is already greater than the maximum one, update maximum one. And in the end, return maximum distance we have captured so far. So this is the main portion. How do we take care of this? So here, if we have K to utilize, just utilize it. And when do I have to utilize? If this character is not equal to horizontal wala character and this character is not equal to vertical character. If it is not equal to any one of these characters, then I have to do something. What I have to do? I have to make that specific direction, whatever is the direction, to any one of these two directions. So what direction you want to make? So let's make the character is equal to horizontal character, and it is something utilizing one operation. So when utilizing one operation means utilizing one value of K. So this is the code, and this code is something greedy. And here, what is the time complexity? Why I just directly came up with the greedy approach? Because I thought of doing it. Firstly, let's try to understand what is the time complexity. Time complexity is I'm going in this direction, fixing this direction, fixing this direction, fixing this direction. So 4 directions I have fixed. And after fixing this 4 direction, I am going over the value of s. So it is 4 into n. That is order of n time. Order of n time and order of 1 space. So this is the optimized way of doing it. I am not aware of any of the other approach, but maybe let's say if you are not able to come up with this scenario, that okay, we have to go in these 2 directions, then you just apply the same way. Just think recursively, north, west, south, east. So how did I came to this approach? If I have K present, it means I can convert this value. Convert this value to what? Either leave it like this or convert it to east or convert it to west or convert it to south. So this direction can be converted to, leave it like this, convert to E, convert to W, convert to S. So these are my 4 scenarios. And again, for the second one, I will make 4 scenario if I have k. If I don't have k, I will just go ahead with this one direction. So every time, in the worst case, we can make 4 moves for these n oppositions. So every time it is 4 move. So for n position, 4, 4, 4, 4. So in this case, it can go till 4 raised power n time. And we have to generate the values in this recursion. So recursion is not a good choice here. It's way more taking time as compared to this our greedy approach. Now let me show you the code for this approach, and in case you are not able to think of it or not understanding it, this approach, just I will request you to watch this portion again where I am explaining this section, that how we are avoiding the bad move, as this is a bad move, how we are avoiding it, and how we are able to come up with these 4 directions are something we have to go. Now let's have a look on this code. I'm trying all the 4 combinations. So these are the directions where I'm going to get the better Manhattan distance. My distance is getting incremented because I'm going this one direction of this combination, like east or north or west, like this. So for every these 4 combinations, what I'm doing is I'm starting my journey from origin, and I have k values. K are the options that is allowed to us, k operation we can perform. Now process this string. Processing this string, if I do not have k, then it is something, just go with the flow, go within the same direction whatever is given to you. Otherwise, if you have the option, just try to correct the bad move to the good move. And what is good move? Good move is something choosing the same direction that I have chosen in the starting, because I'm exploring all these 4 directions. So if I am choosing east and north, then try to go greedily in this direction, and at the end if you have the Manhattan distance, maximum distance from all of these situations. And this code is working fine. I am attaching the code in the description below. You can have a look. And I have not gone through the editorial and all, whatever the approach they are using. So I found this intuitive after the recursive thinking. So recursion is not possible here because of 4 raised to power n time complexity. And this is just directly taking order of n time and order of 1 space. Thank you guys. Thanks for watching. Bye bye. In case you get any doubt, you can comment down below or have a discussion in the Discord community. I will be available there. Thank you.